Hi, this is Jim. I just thought I'd document this problem and the fix for it because it's been a very difficult problem to resolve. There's not a lot of information on the web on how to do this, and I did find one really good link that explains the wiring diagram and the issue that I'll share on this video post that you can go to, plus other couple video posts. Special thanks to the guys out at Spring Trains in Texas for pointing me in the right direction as well and helping me get this resolved. Okay, so the problem is this. I'm using Digitrax equipment. You see I got the controller. I got JMRI as my software. These are Kato switches. And you see I got the BDL, what is this, 168, I believe. Yeah, the BDL168 right here. I know it looks like a mess because it is. I've been experimenting. I got a signaling over here. So I've been kind of busy using this as a test bed to understand how everything works before I apply it to my larger set. The problem is this. This Kato switch, 2 or 3 years ago, they have a thing called a DS51K, which is a little decoder that you can mount underneath this switch, and you can draw the power directly from the track, which enables you just to plug in the switch anywhere, and it works. Very cool thing, because then you don't have to drop any wires underneath the table to the power bus or anything. You can basically just plug it in the track, it pulls the power of the track, it's DCC enabled, and away you go. You can switch it back and forth using just track power. So there it goes, boom, boom. Pretty nice, right? So I was pretty excited about that years ago when I set that up. But then I got into this thing, what I'm doing now, which is looking into doing block management with this BDL168. Problem with the BDL168 is the way that it works is it looks for a power draw by the locomotive as it goes around the track to set off occupancy on where the train is. So it's measuring the current draw, I guess, across the rails, and that gives it the ability to tell you where the train is. If you look at my diagram, you can see the left circle is lit up because that is where the train is. The right circle is lit up though, and there's nothing there. This is the right circle, no train. This is the left circle, train. The problem is it's the switch. This little switch right here is drawing power off the track, and it's in this block for this circle. And so as it draws power, it's essentially telling the BDL168 that there's a train there, that there's occupancy. You can even see the little LED tester that comes with this board that I've plugged in, and that little LED on the top right is telling me the same thing as this diagram is, which is also lit up on the right. So it tells me something's there, which isn't what I want. My first solution was to isolate the switch, which kind of sucked, but that works because you just isolate the switch from the whole block and just run it off of the regular bus main, and then that'll work. But then you don't have any visibility to the switch, the occupancy in the switch. So there's an obscure write-up in your manual that you will not be able to understand, and it's let me even look and see if I can find what page it's on. Bear with me. It's in the back of the manual. On page 20, there's this really small write-up, and the key thing is this: resistors added to increase threshold, which is essentially saying I want to turn down the sensitivity of when I see things on that block. When I see something drawing power. It's a weird wiring thing. You have to really look at it because it's called, I think they called it a shunt, where you have a resistor that goes from the power line that runs to that block across to this deal that runs right into the actual Railcom B. So it's a little odd. Like I said, I'll share you a link that has a color diagram that makes it a lot easier to kind of understand that, but believe me, that is the key. The other big deal is to go down to anywhere. Actually, I got these at Radio Shack, and buy these. They're called, I'll probably mispronounce it because I'm not an electrical guy, potentiometer. This is a 1K potentiometer doohickey. And on the end there's a screw where you can adjust the resistance level. So it's like a variable resistor. And so you can dial up the resistance or dial it down by turning that screw on the end of it. So I'm going to attempt to show you the wiring here, but it's a mess. I don't know if it'll be helpful or not, but the diagram shows it as well. But here we go. Here's what it is. Right here is my lead that runs out to zone D, block 1. I've combined the wire that goes to the block out to the actual track to this resistor. So they're both like wired together and stuck in there, and that eventually flows into here, right? So this thing is basically hooked to the resistor, and the other wire, the blue wire, is actually going out to the track. I'll try and follow it, but there it goes off into the track over here for that block, right? So there are the two pieces of that. And then the black wire goes to this yellow wire. It's on the same little grid. They're connected by this little thing here. That wire is that common, I don't want to call it a common ground, but it's a zone common is what they call it in the diagram, which are those yellow wires that come off here that you see for each zone. All that I have hooked together through this little thing, right? And then eventually that wire comes out to this block, and I've got it wired on the other side of the resistor. So here's the deal. Right now you see it lit up, showing occupancy where there is no occupancy, because that's way over here where there's no train, and you see it lit up over here in JMRI. They all agree, right? So now what I'm going to do, and I don't know if I can do this, but I'm going to do it. I don't think I can show the actual doing of it, but hang on, let me find my screwdriver for this. Bear with me. All right, so I'm going to turn this little deal right here, this screw on the end, and as I turn it, eventually it's going to, I believe it's lower the ohm number. It starts at 1K ohms. As the number goes down, eventually this light will go off, which will tell me I've dialed in the sensitivity just right to where it's not, seeing anything anymore. Now, I don't think there's any way I can do this and hold the phones because I hold my camera because I only have two hands. So I'm sorry, but I'm just going to have to do this. So let me see if I can get this on here. Yeah, it's not going to work. So let me just do it real quick. You're just going to have to imagine. So I'm going to turn this little screw. Still trying to get it in there because it is pretty cool. And as I turn it, I'm lowering the ohm number, which I don't really understand how that works, but let me get it. I can see the lights already flickering over there for the sensitivity. Boom. So what happens is I'm going to turn it up. Light comes on. I'm going to turn it just down a little bit. Light goes off. So I've adjusted that, and now you see, hey, no occupancy. Doesn't see a train over there anymore. I go to the JMRI screen. It works. The right turn doesn't show anything in it, even though the Kato switch is in that grid. So just to prove it to you, it all works. I'm gonna come over here. I'm gonna start my train up. Bear with me. Okay, here goes the train. It's on its way. So it's going to come around. You'll see the occupancy light come on here correctly. Boom, there it is. Sees the train. And well, evidently I accidentally threw a switch while I was doing this. Hang on, let me fix that real quick. Not a problem. So let me fix this. When you're moving stuff around, things happen. There you go. So here, I'll run it one more time really quick. Believe me, this problem has been almost insurmountable. I'll run the train a little faster. Here it's going around. And here goes the light. Boom. Train is out of the area. It's coming back around. Of course, you can see it on JMRI too. Let me set this down. It works. It's unbelievable. Believe me, this has been like the impossible thing. So I've seen people get frustrated with this because they spend a lot of time soldering in these DS51Ks into their Kato switches, and then they go to do blocks like I'm doing and discover it does not work. The general thinking is now you got to wire it to the main to get it to work, but you do not because of this resistor that you can put in. So like I said, it's a 1K 15 turn potentiometer or whatever. I'm probably mispronouncing it because, like I said, I'm not an electrical guy. It has 3 prongs on it. I had to measure it with an ohm deal, but basically just connect it to 2 and ignore the other, and that's what makes it work as a variable resistor. I hope I got all that right. And it fixes the problem. The nice thing is you can I'm going to hook these up for every single block when I mount this on a board. And then what you got is you have the ability to dial in your sensitivity by block. That's pretty neat because some blocks will have switches, some won't. Some may just have electrical problems and be oversensitive and be giving you false reads of something being there when it's not. Well, this is a way to dial it back. So it makes a very nice little thing to adjust your sensitivity for the block. So I probably, I see I'm at 11 minutes, talk too much, but it's kind of complicated to figure out for someone like me. And like I said, I didn't see, while I found one good write-up that really does a good job of about a paragraph of it, I've also seen a lot of people saying you can't do this. So again, thanks to my guy at Train Store in Spring, Texas for coming up with this idea and having enough knowledge about outdoor railroads and this variable resistance thing to get me down the road on this. So hope y'all enjoyed this video. Hope it was helpful for you. Certainly it's been kind of a quest of mine to get this resolved. Thanks.